All right, let's see if we can do a couple integration examples using the technique of partial fractions. So let's start with this one. Looking at it, again, I might think about u substitution first, but I can see that the du is not going to match up super well. So let's tackle the partial fraction expansion here. So let's see if I can rewrite this fraction. And first of all, as I rewrite it, I'm going to go ahead and see if I can factor the bottom. That's always the first step, to get things factored. So let's see, x. I need to multiply to -8, add to +2, so that'll be a +4 and a -2. Okay. That's just two distinct linear factors, so the partial fraction expansion says that must be something over x plus 4 and something over x minus 2, and the somethings will just be constants. Okay. So again, my first step is to multiply both sides, all three terms, by the common denominator. So by this x plus 4, x minus 2, x plus 4, x minus 2, x plus 4, x minus 2. You'll probably get to the point pretty quickly where you don't need to write all of that out, but on this side, everything cancels. X plus 4's cancel there, and x minus 2's cancel there. So let's rewrite what we've got. I now have 2x plus 14 equals a times x minus 2 plus b times x plus 4. And again, I'll try my substitution technique first and just say, well, if x equals 2, what does this equation turn into? So plugging in 2 for x, I get 18 equals, and this term will drop out, and I'll get b times 6. And dividing both sides by 6, I'll get the b is 3. And I also want to plug in -4 for x, so let's try that. If x is -4, then the equation turns into, let's see, that'd be -8 plus 14 is 6. And plugging in -4 there would give you a times -6 and b times 0. So it looks like a will equal -1, which means I can now rewrite the original integral as the integral of a over x plus 4 plus b, which is 3, over x minus 2. Much easier integrals to do. Again, tiny little u substitutions like in the last video. Not going to be too hard to work out. And I think I might not even finish working those out. Well, here, let's do at least one of them. So this one, u would be x plus 4, and du would be 1 dx. So when you rewrite this integral, I'll factor the -1 out front. So I'll just have 1 over u du, so I'll get negative natural log of u, I get negative natural log of x plus 4. Could do the same thing with the other one. It's going to turn into 3 natural log of x minus 2. And don't forget 1 plus c on the end. Okay, and we're done with that one. All right, let's see if we can take a look at one more example. So let's work on this guy. And again, our first task is to see if we can factor that denominator. So let's see if we can rewrite this thing. It's x squared plus 10x plus 1 over... And you might not be as comfortable factoring something that has 4 terms in it. If you remember the algebraic technique of factoring by grouping, it would say look at the first 2 terms and just see what you can factor out of those. And then it would say do the same thing for the second 2 terms, see what you can factor out of those. And then hopefully the factor is actually common and you can factor that out. X squared minus 1 times x plus 1. And hopefully your good factoring instincts kick in right now and you say x squared plus 1 can be factored a little further. That's x plus 1 times x minus 1 times another x plus 1. Okay, we're fully factored now. So now it looks like x plus 1 quantity squared over x minus 1. And now we need to set up the equivalent fraction on the other side. So let's see what we can do with that. And this time we have a repeated factor. Which means there's actually going to be 3 possible fractions over here. I don't know if you remember the... Oops, that doesn't work well. Let's see. If you remember, when you have a repeated factor, you do the factor and then the factor squared, each with just constants on top. So let's get rid of that and get that back. So we're going to say, hey, there's an x plus 1 factor, so x plus 1 could have been the denominator. And x plus 1 squared could have also been a denominator. And then x minus 1 could have been a denominator. Okay, so let's see what we can do with solving for a, b, and c. We are going to multiply both sides of this equation by the denominator, x plus 1 squared, x minus 1. So again, on the left side, it'll cancel entirely. On the right side, only pieces of it will cancel. Let me skip a step or 2 here. Say left-hand side, all denominators have canceled. On the a term, one of the x plus 1's cancels. So I get a times the other x plus 1 and the x minus 1. Okay, fine. On the b term, both of the x plus 1's cancel because there's 2 in the denominator, so I'm just left with b times x minus 1. And on the c term, the x minus 1 cancels, so I'm left with c x plus 1 quantity squared. Okay, so far so good. Let's see what we can discover about A, B, and C. And I'll just start by saying, let's plug in something that cancels the factors. So let's say if x is negative 1, let's take a look at what we get then. So if x is negative 1, let's see, that'll be 1 minus 10 plus 1, so it'll be negative 8 equals, plug in negative 1. So negative 1 right there, zeroes out. So that's 0 times that whole term. That whole term's gone. I also get b times negative 2. And this term will zero out. So that's fine. I get b is 4. All well and good. Okay, so let's keep going. The other thing I can plug in is if x equals positive 1. If x equals positive 1, the equation looks like 12 equals, and then positive 1 will make that term 0, make that term 0. I'll get c is, say plugging in 1 for x, so I'll get 2 squared 4. So c is 12 divided by 4 is 3. So I found b, and I found c. The only problem left now is that I still don't know a, because a dropped out with each substitution. And what I'm going to end up doing is I'm just somewhat at random here going to pick another value for x, one that's not going to zero out any of the terms. And I could pick any number I want right here. I could pick 7 for x, or 100. Since I haven't used it already, I am going to pick 0. So if x is 0, what will this equation turn into? It'll turn into 1 equals a times, plug 0 in there, 0 in there, a times negative 1, plus b times negative 1, except I already know what b is. I know b is 4. So 4 times negative 1. And when I plug in 0 in the c term, I get c times 1, and again, I know that c is 3. So it might feel like I'm just sort of scrapping for this last term, and I am, but it works, right? This is a scrappy move that's totally legit. So 1 equals negative a minus 1. Add 1 to both sides. So 2 equals negative a, and a equals negative 2. All right, so we have a, b, and c. We could now do the integral. I'm not actually going to finish it off because this video is getting too long already, but it would be 3 terms that would be fairly easy to integrate. So the b term, I should point out, when you do the u substitution on that one, you'll get u squared on the bottom, but we know how to integrate that also. So all 3 of those terms won't be too bad. All right, good luck with your partial fractions homework.